Binary search usually help us to find an element. But what if the element doesn't exist at all? Can we still use binary search to get our answer in O of log n time? So let's find out. Before we start, if you are not familiar with binary search, I highly recommend you to watch my binary search video first. This solution is directly based on that concept. In this problem, we are given a sorted array and a targeted value. If the target exists in the array, we have to return its index. If doesn't exist, then we have to return the position where it should be inserted so the array remains sorted. The brute force solution would check every element one by one, but since the array is already sorted, we can do much better approach using binary search. We first initialize two pointers, left equal to 0 and right equal to n minus 1. Now, now while left is less than or equal to right, we calculate the middle index. If the index is equal to the target, we found the answer and we immediately return its index. If the middle element is smaller than the target, then the target only be present in right side. So we move the left pointer to mid plus 1. Otherwise, the target must be on left side. So we move the right pointer to mid minus 1. We keep shrinking the searching space until the loop ends. Now here the interesting part. If the target is not found, the loop will terminate. At that moment, the left pointer will be pointing exactly to the position where the target should be inserted. So that's why we simply return left. No extra check needed. So let's implement that idea. First take left and right pointer. Left at 0 and right at end of an array, that is nums.size minus 1, and travel a while loop until left is less than or equal to right. Now calculate the mid index. By mid is equal to left plus right divided by 2. Now if the nums at mid is equal to the target, then we return the mid index. Else if nums at mid is less than target, then we increment the left pointer at mid plus 1. Else the else we decrement the right pointer at mid minus 1. Now at the end we return left. There is small issue in this code. In line number 7, we calculate the mid index by left plus right divided by 2. This will create a overflow when left and right are very large. So we use left plus right minus left divided by 2 to avoid this situation. So let's do that. I comment this for, so let's mid is equal to left plus right minus left divided by 2. So let's run this code. Yeah, I forget one. So now let's run this code again. The spelling of target is incorrect. It's run. Now let's submit this. It is submitted. Time complexity of this solution is order of log of n, and the space complexity is O of 1. So let's do dry run of this code for this array. Our target is 2, and the left index is at 0, and right index is at nums.size minus 1, that is 4 minus 1, 3. Since 0 is less than or equal to 3, so this while loop will run, and the mid index will be 0 plus 3 minus 0 divided by 2, that is equal to 1.5. In C++ it will become 1. And since nums of mid is 3, since 3 is greater than the target value 2, so the else condition will run and our right index will become mid minus 1. That is 1 minus 1, 0. Now the while loop will run and the mid index will become 0. So nums at mid is 1 and our target is 2, which is greater than the target. So this else if condition run and our left become mid plus 1, that is 1. Now the left index is greater than the right index. So this while loop will end and at last we return 1. So our answer become 1. And that's how binary search not only find an element but can also tell us exactly where it belongs when it doesn't exist in the array. And that's the solution for LeetCode number 35, insert sorted array. And I will see you in the next video. Thank you for watching.